Hi, this is the last video for this unit. This is going to show you how to solve a mass-to-mass stoichiometry problem. And we call it mass-to-mass because we are given a quantity in grams and we are looking for a quantity in grams of a different compound. So I'm using the same equation that's been balanced as I have for the last two videos. And my question is, if I react 26.2 grams of potassium chloride, what mass of potassium phosphate will result? Well, since I'm looking at masses for both of my compounds, for KCl and for potassium phosphate, right away what I'm going to do is calculate the molar mass of each. So to do that, I have to look at my periodic table, so I hope you guys still have it. And for potassium chloride, I'm going to add the mass of potassium, which is 39.10, to 35.45 for chloride, and I get 74.55 grams, which is equal to 1 mole of potassium chloride. And for potassium phosphate, I'm going to add 3 times 39.10 plus 30.97 for phosphorus plus 4 times 16 for oxygen. And my total for that is 212.27 grams, which is also equal to 1 mole of this substance. So I'm just going to put a box around these so that I don't lose these molar masses, because I am going to be using them in my dimensional analysis grid. Alright, so now that I've done that, I can start to solve the problem. So just like with any stoichiometry problem, you always start with what we're given. What we're given here is 26.2 grams of potassium chloride. So I'm going to write that first. So remember, like, what we've got to do here is we have to change grams of KCl to moles of KCl so that we can use the mole ratio to switch from KCl to K3PO4. Then we're going to be changing moles of potassium phosphate to grams of potassium phosphate. So this problem becomes a little bit longer. All right, in my next section for grams of potassium chloride, I'm just got to demote the unit, grams of KCl, and that's going to be equal to moles of KCl. All right, so I know that 1 mole of potassium chloride is equal to 74.55 grams, and that's going to knock out my grams of potassium chloride. But what I have left is moles of KCl, and that's not what I'm looking for. I'm looking for grams of potassium phosphate, so I need to keep going. Demote the unit. And I'm going to put moles of the compound that I'm looking for on top. Now, where do I get the numbers for each of these? I have to look back at my equation. Look at the coefficient. The coefficient in front of potassium chloride is 3, so I'm going to put a 3 down here. The coefficient for potassium phosphate is a 1. It's invisible. It's just a 1, so I'm going to put that here. Now my moles of potassium chloride go away, and what I'm left with is 1 mole of potassium phosphate. So by using this mole ratio from the equation, I have switched from talking, in quotes, talking about potassium chloride to talking about K3PO4, which is what we want. So I'm going to demote my unit again, because I don't want moles of potassium phosphate. I want grams. What mass will result? I want grams of potassium phosphate. So I need to change moles of potassium phosphate to grams. Well, just from my calculation that I made over here, I know that 1 mole of potassium phosphate is equal to 212.27 grams of potassium phosphate. moles of potassium phosphate go away, and I am now left with what it was that I was actually looking for, the mass of potassium phosphate. So now in order to solve, I have to multiply my numbers across the top. So what I get is 26.2 times 212.27, and I get 5,561.47. I'm going to divide that by 74.55 times 3, and that is 223.65. And when I divide these two out, I get 24.87 grams of potassium phosphate. So what this means is, in this reaction, if I react 26.2 grams of potassium chloride with enough hydrogen phosphate, my yield, or my theoretical yield of potassium phosphate, should be 24.87 grams, as long as nothing goes wrong in my experiment. So that is your answer for this problem. Let's take a look at the next problem. Same equation, different question. If I want to produce 0.25 grams of HCl, what mass of H3PO4, hydrogen phosphate, do I start with? So again, this is one of the ones that I know what I want to end up with, so what do I have to react? Even though it sounds like we're starting from the end, that's okay. We're able to do that with stoichiometry. So once again, since I'm using masses with these two compounds, the very first thing that I'm going to do is calculate out the molar mass of each. So I did HCl in, oh no, I didn't. So HCl is going to be 1.01 for the molar mass of hydrogen, plus 35.45 for the molar mass of chlorine, and I get 36.46 grams, which is equal to 1 mole of HCl. So there's my first little calculation. Next, for this, I have 3 times 1.01 for those 3 hydrogens, plus 30.97 for phosphorus, plus 4 times 16 for the 4 oxygens. And when I add all of those up, I get 98 grams, which is equal to 1 mole of this substance. Okay, so I'm going to start with what I'm given, change the given mass to moles, use the mole ratio, and then change moles of the new compound to grams of the new compound. 0.25 grams of HCl goes there. Demote the unit. We're changing it to moles, so I'm going to put moles of HCl at the top. And I've made this calculation, so I'm going to put 36.46 grams of HCl is equal to 1 mole of HCl. Grams of HCl goes away. Demote the unit. Mole of HCl. So now that I have moles of one of the compounds on the bottom, I'm going to use the mole ratio to change from HCl to the compound that we're looking for. So I'm going to put moles of H3PO4 at the top. And the numbers that go here, I get from the equation. So in front of HCl, I have a 3, so I'm going to put a 3 down here. And in front of H3PO4, I have nothing, so I'm going to put a 1 here. Moles of HCl goes away. And I'm left with moles of H3PO4, but that's not what I want. I want grams. So I'm going to do one more section. I'm going to put moles of H3PO4 here at the bottom, and I'm going to change that to grams of H3PO4. I know from my equation right here that 1 mole of H3PO4 is equal to 98 grams of H3PO4. Moles of hydrogen phosphate go away, and this is what I need to calculate. I'm going to multiply 0.25 times 98, and I'm going to divide that by 36.46 times 3. So I have 0.25 times 98. I'm going to divide that by 36.46 times 3. And when I do that, I get 0.22 grams of H3PO4. And this is my final answer. What this answer means is that if I want to produce 0.25 grams of hydrogen chloride, then I need to react 0.22 grams of hydrogen phosphate with enough potassium chloride in order to get that 0.25 grams of hydrogen chloride. So let's just review what we did here. Step A, we wrote our given. Step B, change mass of the given to moles. Step C, we use the mole ratio in order to change from the given compound to the wanted compound. And then in step D, we changed moles of what was wanted to grams of what was wanted. And we came up with our answer. I hope this helps you out. Have a good night.